All right, continuing in Chapter 3, Lesson 4. Now, hopefully you have found that most of these assignments so far in Chapter 3 have been really easy. I'm hoping that every paper I get back to you is all 100%, or at least A's. I mean, we all make some mistakes, right? Maybe we forgot a negative sign, or we forgot, something like a label, and so I didn't get 100%. But these are really supposed to be able to give us A's and raise our grades. Some of us struggled in the beginning with Chapter 1 or Chapter 2. There are a couple things that we missed. Our grade may not be as high as we want it to be, and therefore we have report cards coming up. Chapter 3 is fantastic for raising grades if we pay attention to Mr. Barker, we take our notes and truly understand what is being said, and we take our time and make sure we do our assignments correctly. Okay? Don't rush through your assignments. Take your time. It's not a race. No one in my class will ever and has ever gotten a medal, a reward, candy, or anything else for being first. First doesn't mean anything to me. You doing your best is always what's important. So slow down and do your best. As with every lesson, there are some key concepts that we have to understand. And on this one, there is one key concept. And that key concept you're going to hear me mention over and over and over again until I put it on the board and tell you exactly what it is. See if you can figure out what my key concept is as we're going through this. So now we're going to be comparing. Several things we need to understand on comparing. With these type of things, I see a chart. Understanding charts is vital when it comes to learning information. I have charts in reading, I have charts in math, I have charts in science. In science, on the science fair, you have to create a chart. So just being able to look at a chart and get information from it, that's a life skill. So when I look at that, before I even read the story problem, I can see we're talking about average December temperatures. We've had a couple assignments where we've had average questions, even though I haven't taught you averages, because it's a 4th and 5th grade lesson, but we will do some more of them. It's where I take a total of however many are there, and I divide them by how many are there. If I have 5 different amounts, I add them all together and get their total, and then I divide by 5. In this case, it says the average December. There are 31 days in December, right? So if I have 31 days in December, I add all their temperatures together and then divide by 31. So I know in these 1, 2, 3, 4, 5 cities, I know it's a city, that's what it says, they added all 31 days and divided it by 31, and now we have a whole bunch of weird numbers. Those are really cold days, right? Well, scientifically, I should know and expect colder days because we've already talked about this. In December, our axis is tilted away from the sun. We know that that's our December solstice, which is the coldest part of our year in the northern hemisphere. And therefore, I would expect colder temperatures. When I read it then, it tells me exactly what to do. If I just start plotting and thinking, I got this, and I end up with 5 markings on my number line, it's not what it's asking me to do. I only need 2. In order to mark things on a number line, though, I need to know what the tick marks say. Sometimes it counts by 1, sometimes they count by 2s, sometimes they count by 5s, sometimes, like in this case, they count by fractions or decimals. When I see decimals here, then I'm going to consider these as decimals. And I have to know how many there are from one number to the next. Well, the 2 that I'm looking at are Boise and Indianapolis according to this. So I only need to be able to plot the -6/10 and the -1. Where the -6/10 goes is what I have to figure out with my tick marks. So when I count, and I have a couple of you that mess this up, and it's okay because you just didn't get it before. So if you're paying attention now, you'll get it and you'll never mess it up again. I always put my finger on where I'm starting to figure out what the value of my tick marks is. And then I count how many there are. Some of you count where your finger is. I don't do that because it throws it off. Some of you don't count the one that you land on, and then that throws it off. So if I put my finger on the 0 and it goes to the -1 and count how many tick marks it takes to actually reach the -1, then I know how many are there. So I have 1, 2, 3, 4, 5. It takes me 5 to get to the -1. I do count the 1 with the -1. So if there are 5, then that tells me that each is worth what? 2/10, right? Because 2 times 5 gives me 10, which would be a value of -1. So I have -2/10 for every one of them. If I want to plot the -6, then I can count by 2s. So I have 2, 4, 6. That tells me that the 1 for Indianapolis, the -6, is going to be right there. Then the -1, well, that's obvious. It already has its own tick mark and it's already labeled for me. So I know Boise is going to go there. Now, What I have to understand here is when it says which one is greater, that's the value that is closest to 0. Always in negative numbers. If we're doing positive, it's just the opposite. So one of the ways to look at it is if I'm going from left to right. So in negatives, the further right that I go, where the 0 is, it has a greater value. And positives also, the further to the right I go, the greater the value. If I go to 1,000,000, it's definitely greater than 1. In the same way, on the negative side, if I go from a -1,000,000 to -1, -1 is greater. Because the closer to 0 than I am, the greater its value. So since -0.6 or -0.6 is closer to 0, it's to the right of the other number, then I know that Indianapolis has the greater temperature. All right, so what about this one? Oh, it's the same information, isn't it? This time it says use place values to figure out the greater amount. So there's more than one way to do these. Always more than one way to do a math problem, right? Which one do you have to do? Hopefully you said in your head, the one that I understand best. When I look at Indianapolis at -0.6 or -0.6, and I look at Boise, it really doesn't have a decimal, does it? So I'm going to add a decimal. So it's just -1.0, right? So if I had -10 and -0.6, then I know the further away I go from the 0, the smaller the value, or the closer to the 0 I get, the greater the value in negative numbers. So that would also tell me that Indianapolis is going to be greater. Because as I think about it, then I have -1, and 0 is greater than -1, and since -6 is closest to it, -6 is greater than -1. So I know -6 degrees is warmer than -1 degrees. So Indianapolis has a greater average December temperature than Boise. Right? Should make sense. Hopefully it does. What if we take the same idea and we switch it around a little bit? Well, how can we switch it if we said closer to 0, the greater the value always is if we're talking about negatives? Well, notice on this one, we went from a horizontal number line to a vertical number line. Positives are always going up, negatives are always going down. In this scenario, we're talking about elevation. I know because my chart says elevation. What does elevation mean? I know what an elevator is. Well, elevator is still going to have the same root word of elevate. I can either elevate up or I can elevate down. That's what an elevator does, right? Elevation means where am I according to ground level. Do I go up and therefore I'm climbing a hill, or do I go down and I'm digging a hole? In this situation, we're talking about fossils. How do I know we're talking about fossils? Because the topic of it is fossils. I know I found 3 different objects. I found a fossil of a shell, a fossil of a fern, and a fossil of a fish. And they were all found at different elevations, or in this case, these 2 were found at different depths because they are negatives. This one was found further up, maybe up on a little bit of a hill, because it's a positive. The question asked me, though, the elevation of objects found at a dig site are recorded in the table. Which object was found in a lower elevation? The fossil of the shell or the fossil of the fish? So I only have to use 2, but I have to figure out where they would go on this number line. Now, these are fractions, right? I still have to figure out what my tick marks are telling me as far as fractions. So when I go from 0 to -1, I have 1, 2, 3, 4. The first one had 5, right? So I knew it was 0.2. Well, now I have 4. So fractions, let's see. So, well, out of 4, then that means I have 1/4, 2/4, 3/4, 4/4, right? Because my denominator tells me how many pieces, my numerator tells me how many I'm going to use. Okay, easy enough. So when I know that I'm a negative number, then vertically, instead of going to the left horizontally, I know I'm going down vertically on my number line. When I look at them then, if I look at -3/2 to begin, well, I know that -3/2 is going to be below that, the -3 1/4. How is that? The denominator is smaller than this denominator. Well, when I go halfway, that just means from point A to point B, I go in the middle. Or when I say I'm going to go down 1 for every 2, because that's what the numerator tells me of the denominator, I go to the -1 and I go down 1, I go to the second one. So that's halfway. There's 1, 2, 3, 4, have to go down 2. So when I plot that, I know that I have my negative 3 1/2 here. And when I do my negative 3 1/4, I'm only using 1 out of the 4 total. So I only have to go down 1 tick mark. So which one is further down? Which one has the less value? Which one is furthest away from the 0? Well, that's going to be, sorry, went too fast. That's going to be my negative 3 1/2. All right, so here's another way I can look at it. If I don't want to do the number line, can I just look at my denominators? We talked about fractions, comparing fractions, and we know in order to compare fractions, we have to have common denominators. And then I would tell you, yeah, you sure can. Let's find common denominators. When I have 2 and 4 as my denominators, my first question would be, would my 2 go into my 4 evenly? Yeah, sure will. So I know I'm going to keep 4 as my common denominator. So that mixed number, the negative 3 1/4, is just going to stay the same. I have to get a 4 over here. What am I doing to 2 to get 4? Well, 2 times 2 is 4, and therefore I know I have to multiply the top by 2, and that gives me 1 times 2, which is 2. So that tells me that negative 3 1/2 is the same as negative 3 2/4. All right. So now as I look at those, we're talking about getting further away from the 0, right? So if negative 2/4 is what? It's going to be less because the 2 tells me to go 2 steps to the left, to where the 1 tells me to go only 1 step to the left. Okay? So if I have 4 steps back and I only go 1 step, I'm still closer to 0. To where if I go 2 steps, I'm further away, the smaller the value. Therefore, negative 3 1/2 is less than negative 3 1/4. Either way, it shows me the same thing, that 3 1/2 was deeper, so the shell was found deeper than what the fish was. All right, so we got 2 ways we can look at it, right? Well, no, this says we actually got 3 ways we can look at some of them. So don't let this confuse you. It is a lot of busy stuff, but they're showing you that there are 3 ways to do this math problem, and whichever way you choose to do it because you like it best is absolutely fine with me. Always more than one way to do a math problem, way to see it. So we're going to do fractions, then we're going to do decimals, then we're going to do number lines, and all 3 ways we should end up with the exact same answer. It says to convert to all fractions or all decimals so that I can do what? So that I compare greater than, less than, or equal to. So I know I'm going to have little arrows, and the arrow always points to the smallest number, right? Well, this one doesn't show me to have arrows. It's just going to tell me to answer the question. All right, that works also. So we start with fractions. If I know how to say this correctly, still working on that with some of you. Because some of you want to tell me, well, it's negative 0.1. That's not the correct name. If I know that that's in the 10th place, then I know it's negative 1/10. Okay, so if that's a negative 1/10, and this is negative 4/5, that tells me I need a common denominator. I want to keep this one because it's already there. So what about the 5? What would I do to the 5 to get a 10? Well, I have to multiply it by 2. And if I multiply my denominator by 2, I have to multiply my numerator by 2, and that gives me 4 times 2. That's going to be a negative 8. So I'm keeping my negative 1 because this is negative 1/10, but I'm changing this one into negative 8. So which one is further away from the 0? Well, if I have a common denominator, negative 1 is 1 step back, negative 8, well, it's pretty far away, isn't it? So I know the negative 8 has to have the smaller value than the negative 1. What about decimals? We have 1 decimal, let's keep it. So this is set as negative 1/10. What is negative 4/5? Well, I could change it to a common denominator, hint, hint. But if I didn't do that, then I would do what in order to change my fraction into a decimal? And hopefully you said, well, I know that fractions are division, so I would divide. And which one goes inside my division box? The numerator, right? The top number always goes inside my division box. So when I divide, then I have my 4 divided by my 5, which some of us would say, well, we couldn't do that before, but now I can because I know how to change fractions into decimals. So I add my decimal and my 0 and I divide, and I know 5 goes into 40 8 times. So I'm talking about a negative 0.8 or a negative 8/10. Once again, negative 1 step back or negative 8 steps back, which one is going to be less? Negative 8/10 is less than the negative 1. Could also use a number line if I know where they go. So when we look at it, we have the 1, or the 0. Notice that the negative 1/10 is right in the middle because we have 1, 2, 3, 4, 5, and therefore each one would have to be worth a 1/10, right? That's why this one is 1, 2, 3, 4. This one goes here, this one goes here. Which one's further away from 0? This one has to be the greater value. So here's the key to the lesson. Remember, the further left you go, the smaller the value is. Always going to be the case when it comes to positive and negative numbers. That takes us to our lesson. Looking at how we're going to write our answers is going to be key, right? It's important to understand. It's important to follow along. It's important to build that muscle memory so our pencil's in our hand. Our brains are engaged and our ears are working and we're actually listening and learning while Mr. Barker is talking because he's kind of strange. So when I look at these then, I start with negative 0.3 and 0.2. So negative 3/10 and 2/10. Well, that one should be pretty easy, right? If I know that negative 3/10 is always going to be to the left, but 2/10 is always going to be to the right, then negative 3 has to be less because it's a negative. So if there's a positive versus a negative and it tells you to use an arrow to point to the smallest one, you should always point to the negative number. In the same way on number 1, I have positive versus negative, or excuse me, number 2, it should point to the negative number. However, when I come down here, I have 2 negatives, don't I? So when I have 2 negatives, and they are both decimals, I just have to remember how many steps away from 0 I'm going. And the further to the left I go, the smaller the value is. So when I'm taking 8 steps versus 5 steps, I know that my negative 8 is the smaller value. Once again, it's just the opposite of positive. So it's the idea of going further to the left is the smaller the value is. Now on 4, I have to do some work. I either have to make it into a decimal or I have to make it into the 7/10 into a fraction with a common denominator. Well, I'm going to choose to make that into a fraction and have the same number, take the fraction and make it into a decimal and find the same number of decimal spaces. I find that a little bit easier most of the time when I'm comparing numbers. So instead of trying to come up with a common denominator between the two, then I'm going to just divide and come up with the decimal. Top number once again goes inside the box, so I have 3 divided by 4. I add my decimal and my 0 and I start dividing. 4 goes into 37 times, because 7 times 4 is 28. I have 2 left over, and then I bring down a 0, which tells me that 4 goes into 25 times. So I know that 3 out of 4 quarters when it comes to money is 75 cents, and we're proving that it is 0.75. When I have 0.75 or 75 hundredths, then I notice I have 2 decimal spaces. Notice that I only have 1. I need 2 over there. That's how I compare decimals. And then I look to see which one's closer to 0. Closer to 0 means a greater amount, or I see which one's further away from 0, which means that it's going to be less. So 75 hundredths is further to the left, it's less, smaller value than the 7/10 or the negative 70 hundredths. When I order them, if I can figure out what the biggest number is, because it's positive compared to negatives, I would just write it down. I say that because on this one, notice I have 1 positive and 2 negatives. So the 1 positive tells me it has to be my greatest value. This says to put them in order from least to greatest. Not all of your homework assignments will say put them in order from least to greatest. So it's important to listen and pay attention. I know that one has to be listed first. Then if I just look at my whole numbers, I know the further to the left I go on my decimals, the smaller the value. So that tells me that the negative 7 1/10 has to be the furthest one away. That just leaves me with my negative 5 9/10, which is going to be in the middle. Some are as easy as that because these are fractions and that gets a little wackadoodle trying to come up with a common denominator, doesn't it? Well, I'm going to start with the same way that I did with question 5. Is there a positive? Yes. Is there more than 1 positive? No. So I know the 1/9 has to be my greatest value. Now when I look at the 6 7ths and the 2/3, if I come up with 1 common denominator between 2 fractions, It makes my life a little easier. Could I divide to come up with these answers? I could, but I did that up there. So now I'm going to, for those of you that prefer decimals, we're going to do, or fractions, we're going to come up with a common denominator. And once again, I see if my smallest one will go into my biggest one evenly. It won't. So I'm just going to multiply by opposite denominators. Here I'm going to multiply by 3's, and therefore over here, I'm going to multiply by 7's. When I multiply by 3's, I get 7 times 3 is 21, and 6 times 3 is 18. This 7 then, I'm going to multiply. I get 3 times 7, that once again is 21, which is my goal, the common denominator, and 2 times 7 is 14. Which one is further away from 0? Which one do I have to take the more steps on? Well, that's going to be the 18, right? So remember, I have to then write it correctly in its original form on my answer line. So I know that the negative 6/7 is further away from the 0, and the negative 2/3 is closer. So they should go in that order. When I have number 7 then, I have 2 decimals, I have 1 fraction, and they're all negative. So I don't automatically know which one is the biggest. But what do I notice about the whole numbers? One's a 6 and 2 of them are 5's, right? And 6 is always further away from the 0. So I know, without having to do any math yet, that that's going to be my smallest number. Now I can figure out which is my biggest and my middle. I'm just going to divide on these. This one's a decimal, and I know because that one was kind of done for me talking about quarters. So if you already know that 1/4, 1/4 is worth 25 cents, then you already know how to change that into a decimal. And if you don't, then you would just have to divide your 1 by your 4, which allows you to get 4 going into 10 2 times, having a remainder because it's 8. And I get 2, I bring down a 0, and now 4 goes in 25 times. It is 25 cents. So I know that this is the same as 5.25 or 5 and 25 hundredths. This one is the negative 3. So when I look at those, I don't have the same number of decimal spaces. I need it in order to compare. So when I see it, I might have said, well, I know that 3 steps is closer than 25 steps, and that would be true if I wasn't dealing with decimals. Dealing with decimals, I have to have the same number of decimal spaces, so that I know what I'm looking at is taking 30 steps to the left or 25 steps to the left. That tells me then that the one further away is the 30 steps. So my negative 5 and 3/10 is written down, and then my negative 5 and 1/4, remember to put it back into its original form, has to be the greater value. All right, so now we're going to do a story problem. This is not difficult, but some of you give up on me before you even think about it because you don't want to read all that. Reading is life. We got to be able to read it, so it's okay. Last week, Wednesday's low temperature was negative 4 5/10 degrees Fahrenheit. Thursday's low temperature was a negative 1 2/10 degrees Fahrenheit. Friday's low temperature was negative 2 7/10 degrees Fahrenheit. And Saturday's low temperature was negative 5/10 degrees Fahrenheit. The average low temperature for the week was, so they added those 4 together and divided by 4, and they got negative 1.5 or negative 1 5/10. How many of these days had low temperatures less than the average low temperature for the week? Remember, the key is the further away I go from 0, the smaller the amount. If negative 1 5/10 is my baseline, the further away from it has to be a lower value. So I need either a larger number or maybe a larger decimal. So do I have any where my whole numbers are greater than negative 1? Yeah, I do, don't I? So when I look at it, I have negative 4.5 is definitely further to the left than negative 1. And there's a negative 1. Now the 2 is closer to the 0. That doesn't even have a whole number. That can't work, then it's positive. Negative 2 is further than negative 1. So that one's it. So I have 2, right? So what's my answer? Well, it says how many of these days. It doesn't say which one or anything, so it's 2, right? 2 days. Easy, as I said. Just have to read it. All right, so this is for extra work. One of the things I want to caution you on, though, please look in your book. On your homework, we found this out the very first year. This is a typo by the industry that made the book. This says to order from greatest to least, and notice what these arrows are doing. They're facing one toward another. I'm not saying mathematically you can't do that, but that pattern does not follow what it asks you to do. So this is a typo here. I need to make sure that my arrow is pointing to the right. So please do that in your book. If you didn't watch the video, you might have missed that important key when it comes to your homework. All right, so your assignment is page 161, page questions 2 through 15, and 162, 1 through 6. If you have any questions, come and ask, and we'll look through those review questions. If not, take your time and do it correctly. It's kind of a short video at 25 minutes. So, get your assignment done. Come and ask if you need help.